In this video, we want to take a look at the convergence of power series and the ratio test, which will allow us to find the interval of convergence. So here we go. Again, this is not a course on sequences of series, so we're just going to jump right in with the results here without any proof. The textbook has a little bit more detail into this, but the basic result is there's a value r, a number r, so that this power series converges absolutely for all x on the interval absolute value of x minus x0 is less than r, and diverges for all x, which is outside of that, strictly outside of that interval, x minus x0 in absolute values is greater than r. Okay, so written slightly differently, that interval is all the x's between x minus x0, between x0 minus r and x0 plus r. So x0 is right smack dab in the middle. We talk about this being the power series centered at x0, and because the interval of convergence is actually centered at x0. Notice a couple of things here. In the interval of convergence, on the inside of the interval of convergence, there's no or equal to here, so the endpoints are not included. So inside that open interval, every single value of x would produce a series which converges, right? Outside of that, so where the absolute value is bigger than r, you will definitely get divergence. The equal to r part, it depends on the situation. Sometimes you get convergence, sometimes you don't, and you just have to check the endpoints. Okay. Another thing that could happen here is that r could be infinity, right? To say that there is a value, that value might be infinity, in which case this would say every x works, that the interval of convergence is the whole real line. Okay. Now, to find out what that interval of convergence is, one of our basic tools is what's called the ratio test. Okay, and so I've got this power series, and it converges for all the x's that satisfy this limit. And what this limit is the n plus first term divided by the nth term, and you look at the limit of that as n goes to infinity. And we claim that if we can get this limit less than 1, then the x values that make the limit less than 1 are x values for which you have a convergent series. Now, notice that by looking at the ratio of one term to the previous one is exactly like comparing it to a geometric series. Because for the geometric series, that ratio is always the same, right? From one term to the next term, you're always multiplying by r. So in this case, this ratio would be, if this was a geometric series here, then this would just be r. And it would be less, and if r is less than 1, that's when it converges. So what we're doing is we're looking at each of these series and saying, how do they compare to a geometric series? If we can show that they're behaving like a ratio less than 1, which would be convergent for geometric series, then they will be convergent as well. If the ratio is bigger than 1, then they look like a divergent geometric series and hence diverge. Okay. So here's a couple of examples. I've got the sum, n equals 0 to infinity, 2 over n, n over 2n times x to the n. Okay, so this is centered at 0. So the n plus first term, so all the n's I'm turning into n plus 1's here, divided by the nth term, and then you just got to do a little algebra, dividing by the fraction, inverts and multiplies, then a bunch of x's cancel out. In fact, there's n x's that cancel out, leaving just one x there. The 2 to the n and the 2 to the n plus 1 leaves 1, 2 down in the denominator. All right? And now the limit as n goes to infinity. Well, the x is unaffected by n going to infinity. But this fraction, n plus 1 over 2n, well, that looks essentially like n over n. When n gets big, the plus 1 is irrelevant. N over 2n is a half. And so the limit here as n goes to infinity is a half times the absolute value of x. We want that limit to be less than 1. So I say, okay, now make it less than 1, and what that tells me is that the absolute value of x has to be less than 2. So the interval of convergence for this power series is from -2 to +2. Any value of x inside of that interval, when you plug it in for x and add up that infinite sum, you'll get a finite number. Any value of x outside of that interval, not on the endpoints, but further outside than that, then you will get infinity, or you get something that doesn't converge anyway. On the endpoints, let's take a quick look. If I plug a 2 in for x, right, so I do the upper endpoint here. You plug a 2 in for x, then this is 2 to the n's would cancel out, and you just have the summation of n. So that would be 0 plus 1 plus 2 plus 3 plus 4. That's the sum of the positive integers. That is... I'm chuckling because there's videos you'll find on YouTube showing that that's equal to negative 1/12. It is not equal to negative 12. It diverges, all right? It diverges. Likewise, if you plug a negative 2 in, then the negative 2 to the n would be negative 1 to the n times negative 2 to the n. So the 2 to the n's would cancel out, and what you get is you get an alternating 0 minus 1 plus 2 minus 3 plus 4 minus 5 plus 5 and that plus 6, and that also diverges. So the endpoints are not included here, and it diverges on the endpoints. There's times when it will actually converge on the endpoints, but not today. Okay, and here's one more example, the summation of x to the n over n factorial. We're going to take a look at the limit as n goes to infinity of x to the n plus 1 over n plus 1 factorial. That's the n plus first term here, and then divide by the nth term. Okay, again, dividing by this fraction, you invert and multiply. Just a quick reminder, n factorial means 1 times 2 times 3 times 4 times 5 all the way up to n, right? So n plus 1 factorial will be 1 plus 2 plus 3 plus 4 plus 5 all the way up to n plus 1. Which means if I've got an n factorial on the top and an n plus 1 factorial on the bottom, then the n plus 1 has all the factors of n factorial in it, 1 up to n, plus, not plus, but times 1 more, right? So that cancels out, the n factorial cancels out with the n plus 1 factorial, leaving just the factor of n plus 1. All the other factors cancel out. Now the x to the n, of course, would cancel with the x to the n plus 1, leaving just an x on the top. Now, take the limit as n goes to infinity. There's just an n on the bottom here. So no matter what x you choose, as n goes to infinity, it will eventually get bigger than x, and this fraction will go to 0. So this limit is equal to 0 for all x. And notice, 0 is less than 1. And so this converges for every single value of x for the whole real line. The interval of convergence is minus infinity to infinity. In fact, one of the things we'll see in an upcoming video is that this power series is actually equal to e to the x. So not only does it converge, but I know what it converges to. You plug in 7, it's going to converge to e to the 7, and so on. So anyway, there's some basic information about convergence of power series and the ratio test to find the interval of convergence.